parties involved in the design and construction process of the project. And then we'll look a little bit at parametric modeling. Okay, here we go. Okay, last month in part one of our series, we went over these items. We talked about some brief definitions of what VDC and BIM are. We talked about what BIM is not. We concentrate a lot on waste in the construction industry as compared to much less degree of waste in the manufacturing sectors, and why is there such a difference in these two broad areas. And then we looked at some definitions and talked a little bit about project delivery methods that you can use when you're employing VDC methods during a construction project. And then we looked at LODs, level of development, within the model objects in a 3D model. Okay. Now, to get started with part two, what BIM was first thought about, and the ideas of it began in the late 1970s at Georgia Tech, and in the papers of Charles Eastman, he used the term BIM, or Building Information Modeling, did not exist yet, and the term he used back then was Building Product Model. The actual term Building Information Modeling came from an Autodesk strategist, and the first time BIM was actually, or the early, more primitive uses of BIM occurred in a project in 1987. Okay, when we're talking about BIM and 3D models, we want to compare that a little bit. Just think about 2D drawings. When we were much younger, that's all there was. And we'll talk and think about that the paper plans as depictions. Okay, whereas a 3D model, with all its information and its ability to rotate and visualize and things like that, and you can put time and schedule and money on it, this is simulation. Okay, so think about depiction versus simulation, depiction on paper, simulation in 3D models, and think about modeling versus drafting. Okay? Okay, and then here, here's just an example of a 3D model of some concrete columns, concrete beams, and we're looking in at the rebar. And so think about what you're able to visualize here, looking at the interior of these objects in the model versus what you would see on paper plans. Okay? Now, BIM, is growing. Its use and adoption is growing day by day, and what drove that initial surge was the interest by contractors, not that of architects and other designers. The architects, the designers, they were still tending to stay with the thoughts of the paper plans, the 2D and 3D drawings, and not models, whereas it is the contractors who saw, when they saw these models, they saw the power that these could give the project above and beyond that of your typical standard paper plans. Okay, so these days architects are going to have to develop new ways of thinking about the whole design process, and have what is commonly called a paradigm shift, and to keep up with the contractor's love of the models. Okay, and now more and more owners are requiring that models be provided. Okay, and that they come from the architects. And thus, the term we like to use is that they must embrace the strange. This is the new thing, the 3D models, all that. And as time goes by, it'll be less and less strange. It'll be more and more common, and it will eventually be the only way to do things. Okay. Now, let's think about the concept of parts. Again, last session we talked in depth about the degree of waste, that is non-value adding time and money spent on projects that are by definition classified as waste. Okay, the percentage in the construction industry as compared to the overall manufacturing industry was tremendously different. Okay, what's one of the reasons that this exists? That's because in the manufacturing areas, they have bills of materials, and they have extensive part lists, very, very detailed, and they're all integrated. Whereas the construction industry, yes, there is parts, they know some things, but it's not a completely integrated idea or set of things that is analogous to the manufacturing industry's bill of materials. Okay. Also, and we're going to get into a definition of parts in just a moment. But be aware that, let's think about composite materials, okay, versus what we perceive as parts. And that's going to change the way you think of a certain object or item that's used in construction processes. Okay, we are going to define a part, and this is how we define the term part at Stanford, is that it is a single physical entity that is installed on site, not prefabricated off site, by a specific activity. Okay, off site prefabrication reduces the number of parts. So this prefabricated item you might say, oh, well, that contains 382 parts. Well, no, if it is one object that is installed by one specific activity on the job, then that's a single part. Okay, whereas we can, though it is physically made of all these different individual items, it was prefabricated off-site. A big part of the definition of part is that it is an on-site effort. Okay? Now, let's think about this. Okay, we looked at a model, and it had 110,000 objects within that model. That these are, we'll call them BIM objects. Okay? Now, these 110,000 objects represented 6 million parts, given that we're adhering to that definition we just talked about, the on-site installation. Okay, so if you know the total number of parts in the whole project, that's going to give you some kind of insight as to what's going on in the project and the massiveness of it or lack thereof. Okay, as this concept of parts and this integrated information platform for AEC is developed and comes to be more and more up to the level of manufacturers' bills of materials, okay, that's going to contribute in the future toward this reduction of the waste and rework as opposed to the manufacturing industry. And we'll see that waste gap narrow a little bit. Okay, again, here's just a 3D model of a structural portion of a project. Okay, Now, let's start talking about the different dimensions in BIM, okay? Talk about 2D. Okay, that's common, traditional paper drawings, and that includes CAD, okay? And that's the plans, sections, elevations, etc., whether it was drawn by the human hand or by the computer in a CAD system, okay? That's 2D. It's not, we're not talking about perspectives and things like that. 3D is going to include the virtual 3D models found in BIM, and it would be physical cardboard models an architect might build, and renderings and isometrics depicting the 3D world on a sheet of paper. Okay, so that's 2D and 3D. We're starting to move a little closer into getting these things together in BIM. Okay, in the models. Okay, a 4D model is going to contain the three physical dimensions, X, Y, and Z, Cartesian coordinates. It's also going to have time in it. Okay, that's your CPM schedules and sequences and things like that. And from this, you can develop animations, given that you've got a virtual model. Okay, so we can start visualizing and making the sequence come alive, the schedule come alive, as you can see it on the screen as the 3D model goes together, given that it's animated and the schedule information is incorporated into the model. Okay, now 5D is the three physical dimensions plus costs. Okay, and that's your cost estimating, information accounting, things like that. So if you say I've got a 5D model, you're going to assume it's the 3D drawing, the model, plus the schedule, plus the estimate, plus cost. Okay. Now 6D is commonly known these days, and this has become a more and more standard definition of what 6D is. That's 3D plus sustainability, and that would be using the model for energy use modeling, energy analysis, material investigation, and lead scoring. Okay. 7D is what is used for facility operations and maintenance. So a model, or the objects within the model that are going to be used for operations, needs to have product information built in to the objects within the model. Okay, and this 7D model is going to represent your as-builts, and again, used by facility managers once we've got handover. Okay, what's coming up? I've seen many other ones going 8D, 9D, 10D, 11D, and there's no standards just yet. Okay, and they're starting to get more and more and more. I don't know when, they're going to go, oh, stop, this is just way too much. We've got a sufficient amount of ND definitions out there to use with BIM and VDC processes. Okay. Now, the reasons, and here's just a laundry list of reasons that BIM is useful, or so useful, so much more useful than just your older paper plans and separate schedules and separate cost estimates, is that, number one, you can have greatly improved visualization. That model gives you a lot of increased visualization that clarifies what the project's all about, what this looks like. You can spin it, look inside, look outside. You can pull it apart. You can take virtual tours, and that would be walkthroughs and fly-throughs. They're really useful with clash detection to detect all kind of problems that might arise on the physical site beforehand, working with the model, so you don't have to remove things you've already installed and put up and redo them again, and spend more labor and do change orders and things like that. Also, these models are real useful in feeding all this good information that it has to the actual workmen out on the site in the crews that are doing the work. There's many terms of this. One of them is called the last 100 feet, and there's the last mile, and the last 40 meters, and the last walkover, so all kind of things like that. But that is the process of having the crews or the crew foreman have a tablet or something similar, and he's able to bring up stuff from the model on his tablet for that day on what the crew's working on to get this information that exists in the project's BIM trailer and on their models and all that to the actual guys that are doing the work. Okay, this is called taking it the last 100 feet, and that's a specific contractor in this country's term for it. And other contractors, like I said, will have different terms to their own proprietary term for defining what that transfer of information from the model to the actual guys that are doing the actual physical work. Okay, BIM models can also, you can flip around alternate materials on facades and on finishes inside and see what things look like, and if there's, again, costs attached to this different facade materials and interior finish and things, see the effect of the on the price of the job. Okay, BIM can also, or BIMs, the models, you can look at different lighting materials and different times of the day and shadows and how the sun affects the appearances and daylighting on interior spaces and things like that. Again, that's something that you can do with a model that you couldn't do actively with paper drawings. You might have different presentation drawings and perspectives of sunlight here and there and here, but here you can have an active way of displaying it and looking at it, okay, in the model. Okay, again, we talked about using the models for cost estimating, using the models for critical path scheduling. You use models for marketing of the project and for press releases to the public with information on the project. We talked about attaching product information to different objects within the model to use it as for facility operations and maintenance. Okay, again, these are new ways of achieving all these activities that we want to achieve on the project. Okay, let's talk a little bit about clash detection. Okay, when you end up actually building and installing and erecting the project materials, you can't have things being in the same place at the same time. They've got to be coordinated and go in the properly designed spaces. Now, this is showing a design that, we've got the ductwork over here, we've got the concrete frame over there, we've got some conduit running through it, and in this example, we're seeing there's all kind of clashes. Okay, you've got to, oh, wow, we can't put that there. We got to put it here. We got to redesign the stuff. So it's better to do it here. Maybe the concrete frame needs to be redesigned a little bit, and you know, if it's already in place and they start trying to put the ductwork in the same place or the conduit in the same place, you've got clashes, okay? So it's better to detect these things early and then take care of those and then resolve the conflicts and go from there, okay? And here's another example. We've got some structural steel that's going to be in place, and then we've got some ductwork in the vicinity, but looking at the picture, you can see that there's a clash there, okay? In this case, the steel structure is not going to be redesigned. They're going to redesign the positioning of the ductwork and sizing of the ductwork, and again, resolve that here and not have this discovered that, oh, we wanted to put this here, but it doesn't fit, okay? You can redesign it so that the things are coordinated and they will physically fit post redesign, okay? And again, here's a third little example of some clashes. We've got some metal studs, and they're designed, they're going to be in a certain place. And then we've got some ductwork that's, some exposed ductwork that's going in there, but whoa, it's bumping into some metal studs. They can't go in the same place. Are we going to move the studs and leave the ductwork in place, or vice versa? Again, that's up to the designers and the decision makers when things like this are discovered. You know, is it okay to move the doors? Is it not okay? You know, whatever. You just got to make decisions based on the fact that you now know that these clashes in the design exist. Okay, let's think a little bit about a few things on clashes. Let's talk about two types of them. There's geometric clashes, okay, between objects that we just looked at a few examples in the slides of, and what we saw was intersection clashes. Okay, there's also clashes where you're defining some distance and clearance settings, and you can set it, say, okay, run my clash detection test, and if something's within such and such a distance of something else that's defined to be compared for clashes, if it's within that range, it's going to set it as a clash, okay? However, you can also have false positives, whereas physically it's going to be fine to have these things within these ranges, and you've just got to look at your clashes and determine if it's a false positive or is it truly a clash, okay? Now, another clash that you can determine using 3D models is crew workspace clashes. Your schedule might say, okay, we're going to do this activity, and this activity all simultaneously, and that may be fine, but you also could determine that there is what we call trade stacking, okay? And that, you know, with the schedule, you know, you don't, the scheduler may or may not be aware of that trade stacking is occurring, but you can use the model to say, oh, we've got too many human beings in one place at one time trying to do different types of work, and we're going to have to adjust the schedule, and let's do that now and not on, you know, that actual physical day when they're getting in there working and they're saying, well, we can't do this, you're here and you're here, and you know, we're running in each other and there's not enough room for all of us to do our work, you know, as it was planned and scheduled. So again, that's something you can help determine and resolve before the physical activities take place. Okay, and again, we're going to talk about individual objects in a second, but and we talked about the level of development last session, and at 500 you've got a lot of data, which, depending on definitions, can be used for FM, facility management. Okay, now let's talk a little bit about model management and ownership and intellectual property and individual object authors and versus contributions to the model. Okay, so what we're about to go over is a little bit about model ownership. We're going to talk about the model's manager and how that changes as the project progresses. Okay, because the overall management of the model may move from architect to general contractor to a major subcontractor, back to the general contractor, over to some engineers, back to a subcontractor, back to the GC. Okay, we'll talk about model access. We'll look at the AIA G202 protocol, and we'll talk about the term right of reliance. Okay. Okay, here's a model, or part of a model, and here's all this stuff in it, and we want to know who's responsible for what. You know, you're going to have typically many different modelers developing the objects within the model for the project. Okay, with the BIM protocol developed by AIA, you're going to help organize the model's data and the objects and put it in a structure that you can work with, as you're building the model and as you're growing the model from LOD 100, 200, up to 400, 500, maybe just 300. Okay. Okay. Contractors are good quality BIM adopting contractors. They're going to have specific and well-detailed sets of BIM standards for the models that they use on their projects, depending on the scope of the project and what the model will be used for. Will it be used fully on the project, and will it be used with VDC methods and BIM methods, or will it be used to a lesser extent? Okay, subcontractors many times are given responsibility of developing models for their area. Okay, that's not always the case, but subcontractors are many times some of the best model builders and contributors in their area for adding to and making quality objects for the model. Okay, as we talked about earlier with the manager of the model, that's going to change through successive project phases as the project progresses. We talked about the general contractor being the main manager, and then the structural steel subcontractor is the main manager for a little while, and then maybe the electrical, maybe the HVAC. It depends on the project and how the phases of the project progress and how they're put together. Okay. Also, back when there was just paper plans, you knew who owned what. We drew those plans, they're ours, here they are for the project. But with BIM, with VDC, okay, there's questions about model ownership and designing and authoring versus contributing, because there may be an object has been modeled in its 3 dimensions, but then others may be contributing the cost to it, the product information, and other things to it. And the protocol is going to help define who the author is versus the contributors. Okay, And again, the E202 was the initial protocol developed by the AIA in 2008, and in 2013 it was revised. It went through a couple of internal phases, and it is now the G202 BIM protocol, and it's updated, since the E202. Okay. Now, be aware that there's not one big model. Okay, it's typically the total model is used from linked models from the different contributors or the different authors. Okay, the structural people may have been given the responsibility of producing the structural part of the model. Okay, and the architect is doing other parts. Subcontractors and HVAC, whatever, are doing additional parts. Okay, but then when they're all linked together, the overall thing is referred to as the federated model. Okay, and you're not going to affect other separate people's models. The structure. Unless you're getting in and redesigning things and all that, attacking one guy's model isn't going to affect someone else's. At this point, we'll talk about something toward the end of this talk about parametrics, and then when things are linked there, you can affect the things depending on how things are linked. Okay. Okay. Here's the idea of the AIA G202 BIM protocol. Okay. In getting things organized and so things can be legally understood and comprehended, this protocol is an attempt at that organization. Okay, it's using a structure based on a combination of uniformat. You can see that over in the picture there. We've got levels, the levels of development, and you've got the MEAs. The MEA is the model element author. That is the original author of the object within the model. Okay, so this protocol defines the different authors at the different levels of development, and it defines where that object is found within the project based on the uniformat structure. Okay, so again, that's the way they're attacking the organization of looking at how a model is put together and who's contributed what, who's authored what, and at what level of detail are we at this point. Okay. Again, the protocol lays out exactly who authored each component, and it tells the subsequent contributors, that they can depend on it because it is at a certain level of development. Okay, and it's going to delegate who is the main manager of the model during the separate phases of the project as things progress. Okay. Again, we talked about MEA, model element author. We talked about putting information into the object to advance its level of development. Again, we defined different levels of development in the last session, and we talked about level of development versus level of detail, and that there is a difference, and we define what those differences are and what each term means. Okay. Again, the protocol is helping to organize whose intellectual property is this object within this model and things like that. Okay. Again, we talked about using the model element table in the G202. And this is the AIA's official list of levels of development and what they are and what they can be used for. Okay. Now, typically, you know, we're defining these levels 100 through 500, and at what stage in design or construction they're used for in that center column, and you know what the objects represent at the various levels on the far right. However, be aware that officially AIA says there's no strict correspondence between the level of development and the design document phase, such as level 100. There's not a strict correspondence between conceptual design and level 100, even though in general that's what these levels represent. Okay, and again, these are the only official AIA levels of development for now. However, different contractors in-house define additional levels for their own use and define it, these LODs a little bit more finely. Okay, let's take a look at the next page here. And here is just an example of an expanded list of LODs as defined, you know, by a specific contractor. Okay, they have added, they've taken the AIA's level 500 and they've expanded it. They've broken it out into 500 and 600, and with the nuances that they define between the two, they're stating that level 500 is an as-built model, but it is not used for facility management until the objects needed for facility management have risen to their definition of level 600. Okay, they've also added a sub-level 450 as at that level you can use information from the model for construction administration. And they've, in the conceptual design phase, they've taken level 150 as a sub-level within 100, and that's defined as space planning. Now again, an individual contractor may in-house in their BIM standards, in the way they do things, might break things out with all these different fine levels, okay? And so, you know, you can see that they've got LODs 100, 200, 300, 400, 500, 600. And notice that, you know, the AIA did give out a structure in the protocol with the numbering system of, you know, N, you know, 3 spaces, like 400, you know, 500. And that allows the in-house, the contractor in-house to start using those numbering levels to mean more and more detail that's again just to them. It's their own private definition, and they may share this with the other modelers and project team managers and designers and engineers on the project. Say, okay, look, here's how we're going to organize the model, and here's what these things mean. And if you've got an object, and remember, it's the objects that contain the level of detail, level of development number, and not the model itself. You don't say the model is a level 500, okay? Because you might have within the entire model different objects with different levels on them, okay? There may be some objects in the model that never need to go beyond 330 in this example set of numbers, okay? Whereas many of the objects that are going to be used for facility management have to be at 610 and 680, okay? So again, this is just a list to give you ideas about how a contractor might use this numbering system to specifically define what an object must contain in order to be stamped with that specific level of development. Okay. Also, for BIM to exist, for its benefits to exist, everybody's got to have access to all of the data found in the model. Okay. You can't say, well, this is my private intellectual property, and yeah, we're using it in the project, but I'm not going to share this information with you. Well, BIM methods and VDC methods used within those project delivery methods that can use VDC, it's required that everybody be able to collaborate and share information and improve the processes on the project, you know, make it a more efficient construction process by doing so. Okay, you can't deny access. Okay, you know, that's just not part of BIM methods or VDC methods. Okay, the sharing of the information, everybody getting access to it, is one of the fundamentals of construction collaboration, and collaboration is one of the fundamental parts of BIM and VDC. Okay, you've also got to have a right of reliance. Okay, you know, you've got to have confidence that the models are what the level of development, what the modeler says that LOD is. Okay, you can't spend time checking and rechecking and all that, you know, given that you have access to it for its accuracy. And this destroys a lot of the efficiencies of the benefits of BIM. Okay, you've got to have a right of reliance. You've got to say, okay, they presented me with this model. You know, we're federating it with the rest of it, and I need to look at this stuff over here. Okay, I've got to believe that they were competent enough to put the model together based on the general contractor's standards. Okay, and that they did adhere to them, and that, you know, this model is at that level. Okay, you've got to have the confidence. Okay, again, this is the right of reliance. Okay, now talk a little bit about parametric modeling. Okay, that is where different objects are connected to one another, and this form of connection is called a data parameter. Okay, let's look at a couple of examples here. Okay, I've got columns, and they are evenly spaced across an area. Okay, I want to maintain that spacing. Okay, if in my design work I change, you know, either lengthen or shorten the length of the area, it's going to remove or add columns to it. However, the spacing is going to be maintained. Okay, in that example, that parameter is called proportional. Okay, now let's think about a partition, and I've got a junction box in it. Okay, and I move the wall. Okay, you know, as I'm designing this, you know, this part of the model. Okay, and I'm not going to move the wall and suddenly the junction box is floating out in space. Okay, the box is going to move with the wall, given that I do move the wall during design. Okay, in that case, the parameter is called connection. Okay, again, we talked about spacing of columns. Here we'll talk about spacing of studs. Again, I want to maintain that spacing, and I'm gonna lengthen the partition. Okay, because I've lengthened the partition and maintained the spacing, it's going to automatically add studs, and that is a parameter called additive. Okay, if I shorten up that partition and maintain the spacing, it's going to take away some studs, and that is a subtractive parameter. Okay. Now, I could have a parameter that's going to maintain the number of studs and alter the spacing. Okay, I may, for whatever design purposes, want that parameter present in that particular partition or run of columns. Okay. Again, we saw a clash earlier where there was some ductwork was clashing with a door stud. Okay. Now, okay, if I move the door, okay, I'm gonna, that's called, we have some obstruction here. However, let's look at this other example, and let's say I've got a room and there's a door in it, and I'm still in the middle of my design. We've already, put the door in the model, and I put in another partition, and suddenly that partition hits the door perpendicularly. Okay, well, now the door is automatically going to move one way or the other based on the parameter that's been defined for those objects, and that parameter is called obstruction. Okay, so it moved automatically without the designer having to move it at that point. Now they may, he may want to move it himself to another position later, but that parameter is going to eliminate the obstruction automatically. Okay? Okay, now change management is having all related objects in some, connected parametrically in some fashion. And we just saw a few of the different examples of different parameters, and that all these things move or change or get spaced or lengthened automatically. And then this increases the time needed to work with the model, because you didn't have to go, I've got to redraw this and remodel this and put this over here. And now you could, of course, do it later, but it's going to automatically do those parameters for you, and then you review them and see what you want to do from there. Okay? I think we're at the end here. And yeah, thanks. Okay, so I think we've had a pretty good session here on part 2. Part 3 coming up, it's going to be called VDC and Technology Adoption. Okay, Michael, I'll give it back to you.
All right, thanks, Rex. I appreciate it. But again, part 3, we're looking at doing that on Thursday, July 30th at 1 p.m. Central Daylight Time. So continue to check your emails, and we'll update you further and let you know exactly what time part 3 will be. Are there any questions before we end today? All right. Well, again, thank you for your time this afternoon. And don't forget about part 3 of our webinar on BIM and VDC, Technology Adoption and VDC, Thursday, July 30th at 1 p.m. Thanks, and have a great day.